Okay, we've got a ladder leaning against the wall of a house. The ladder is 25 feet tall, so I have to picture, they're saying this ladder is going to start falling down the side of the house. So I have to picture as the ladder is falling, I can call it 25 feet because it's not changing. That ladder is going to stay at 25 feet. This distance, the height, that will be changing. So I'll call that Y. This is a right angle. This distance X, the distance of the base of the ladder from the wall, is also going to be changing. So I'm going to call that a variable X. So it's pulled away from the wall at a rate. So that's the rate of change. Since it's being pulled in the X direction, that's going to be the rate of change of X with respect to time. Okay, and that's going to be at 2 feet per second. Now, should we make that negative or positive? Well, X will be growing, so the rate of change, since X is increasing, right, that's the quantity, the rate of change of the quantity should be positive. So we're going to call that a positive dx dt. It's going to be a positive 2. So if we identify what we have here for rates, we've got dx dt equals 2 feet per second. We also have a dy dt, which we don't know, and that's what we're looking for. It says, how fast is the top of the ladder moving down? So that's going to be the rate of change of that segment or that distance, y. So that's going to be dy dt, and we don't know it. So that's what we're trying to find. I do know it should come out to be negative because y is decreasing. The length of y represents that length is getting smaller and smaller and smaller. So if y is decreasing, the rate of change of y, i.e. its derivative, should be negative. All right, so dy dt is what we're looking for. Now we're talking about the lengths of 3 sides of a right triangle, so the formula here is going to be x squared plus y squared equals 25 squared. Pythagorean theorem relates to the lengths of the 3 sides of a right triangle. So I go ahead and take my derivative with respect to time. I get 2x times dx dt plus 2y times dy dt equals 0. All right, so now I'm going to go 2 times, I can start filling in my x's and my y's and my dx dt's. So my dx dt is 2. I don't know my x or my y yet. I'm going to go look for it. I want to solve for dy dt. So what's my x and my y? They say when. They must tell me. When the base of the ladder is 7 feet from the wall. So that's x. They tell us that x is 7. So one thing to note is I can't plug in the 7 up here. Okay, the 7 can only be plugged in after I've taken the derivative and have my related rates equation, which is this step here. So I plug it in the next step. Okay, x is changing, so it has to stay as an x. Once I get my equation that relates my 2 rates, then I can start plugging in stuff because we're now going to freeze that ladder falling at that instant, and the length of x is 7. Now, how do we get the length of y? Well, I can go back to my original Pythagorean theorem. 25 squared is what, 625? I can plug in my x and I get 7 and I can solve for y. I know that that's a Pythagorean triple, so I know it's a 7, 24, 25 triple. So I know y will come out to be 24. So there's my y. I can solve for this dy dt by multiplying this stuff, multiplying that and solving for dy dt. You can pause the video if you need to. To do that, you should end up with negative 7 over 12 feet per second. And that checks out with my negative idea, right? Y is getting smaller, so the rate of change of y should be negative. And that's how fast the ladder is moving down the wall. Part B says, consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle. So we have this same triangle now. Okay, and now we're going to talk about its area. So its area is going to be 1/2 x times y. And I want to do the derivative of this guy and solve for whatever rate they're asking for. So they say find the rate at which the area of the triangle is changing. So I want to find dA dt that means I have an x and a y left in the equation, which means I'm going to need to know what dx dt is already and what dy dt is already. Well, I found dy dt in the last example to be negative 7 over 12 feet per second, and they told us the x dt was going to be 2 feet per second. So we're using our answer from part A. This is product rule. 1/2 x is the first function, y is the second function. So the derivative of A is dA dt. The derivative of the other side is going to be 1/2, that's the derivative of the first, times recopy the second, times dx dt, because I took the derivative of an x with respect to time, plus 1/2 x, recopy that, times the derivative of y, which is a 1, times dy dt, because I took the derivative of a y. So now I can fill in everything on the right side of the equal sign. And again, they're still saying when the base of the ladder is 7 feet from the wall. So my x is still 7 and my y is still 24. So I fill everything in. I get 1/2 times 24 times 2 plus 1/2 times x is 7 times negative 7/12, which was my dy dt. So then when you simplify that whole thing, the rate of change of the area comes out to be 527 over 24 square feet per second. So what that means in context of the problem is that at that moment, if I tick forward another second, I could expect the area of that triangle to increase by 527 over 24 square feet, whatever that number is. If I change it to a decimal, the area would change by that many square feet if I moved up one more second. Okay, and that's really that's the expected change in area. It's not actually what it's going to be. We'll talk about that a little later, but that's what that dA dt represents. So last part says, find the rate at which the angle formed by the ladder in the wall of the house is changing when the base of the ladder is 9 feet from the wall. So notice, first of all, they've changed the base of the ladder to being 9 feet from the wall. So we're going to draw our picture again. They want to know the rate of change of this angle here, so we'll label that now as theta. As the ladder falls, that angle is changing, it's increasing, right? So I expect this answer to be positive. My x and my y are changing, my 25 stays constant. So you don't want to use an equation with x and y in it. I have choices here. I got to have theta in it because they want to know what is the rate at which that angle is changing. And that's going to be in radians. Our rate of change of angles in this will always be in radians per, are we still doing seconds here? Yeah, I don't need the slash. That's always going to be in radians per second. So now we can decide which side we want to use with theta. We can use x or y, and we're going to use it with 25. We're going to write a trig ratio here. A bad choice would be to do the tangent of theta equals x over y because I have 3 variables. And when I go to do the derivative of the right side, I have to do quotient rule. A better choice might be, let's say, sine of theta equals opposite x over 25 over hypotenuse. Now I only have 2 variables. So that's the choice I want to go with. So I'm going to take the derivative on both sides with respect to time. The derivative of sine is cosine of theta times d theta dt, the rate of change of theta with respect to time, equals 1 over 25 times dx dt. What happened here? I can think of x over 25 as 1 over 25 times x. So I just do power rule. This is like x to the first. So the derivative of that just becomes 1 over 25. And then it's times dx dt. d theta dt is what I'm looking for. I know that when the base of the ladder is 9 feet from the wall, so we're going to freeze it in time. I know this distance now is 9 at that moment, right? So x equals 9. We're looking, we have dx dt from, well, hold on. Sorry. I don't think we have dx dt unless they tell us. Find the rate at which the angle formed by the house is changing when the base of the ladder is 9 feet from the wall. Yeah, so let's first figure out, we've got x is 9, right? So let's look at finding what y is first here at this instant. We're going to need that. So we've got our Pythagorean theorem, and when we freeze this ladder at this moment in time, I can solve for y when I plug in 9 for x. It should be squared. So then 25 squared is the 625. 625 minus the 81, I'll get y squared equals 544. Y equals the square root of 544. I'll probably just leave it like that. We're going to need y because now we're going to fill in what we have over here. Cosine of theta is going to be the square root of 544 over 25. How did I get that? That's why I needed to find y. If I look at theta, the cosine of theta is the ratio of the adjacent side over the hypotenuse side. So cosine of theta can get replaced by this fraction because that's what cosine of theta is. Right? So that's why we need to do Pythagorean theorem and find this side y so that I can fill in for cosine of theta. Times d theta dt, the rate of change of that angle is what we're looking for. 1 over 25 times dx dt is 2. They told us that in the original stem, problem stem up here, right? It's the rate of 2 feet per second. That's how fast it's moving away. So now I can solve for d theta dt. You can pause the video here and see if you can do that. You're going to multiply this out, and then you're going to multiply both sides by the reciprocal of that fraction. So you can pause the video and do that. All right, so you should get that d theta dt after simplifying and everything comes down to 2 over the square root of 544 radians per second.